Hi guys, welcome back to Design Blips, and I'm so sorry I haven't posted a video for a long time. I've been a little busy with my projects and everything all this time, but going forward I have promised myself that I'm going to be posting videos regularly to share all the knowledge and information that I know so that you all know too. So please keep looking at the space for more videos and knowledge. Let's go to the subject then. Today's topic is going to be solar design. Yeah, I can call it that. We're going to be looking at the three significant angles in a solar analysis. We're going to be looking at how to read a sun path chart and a few design tips. Very basic guys, very basic. I'm not going into too much of in-depth detailing, but I'm sure this video is definitely going to help you in a different level to design a passive solar. First topic is going to be the three significant angles in a solar analysis. Let's imagine this is your site, and then you have your the building that you're going to be analyzing. It's just a hypothetical building because you need to know how you're going to be applying your design elements on your building in order to make it very efficient according to the solar analysis. I hope I was clear enough. Okay, so here, if you consider this to be a site and this to be your sun. Now the sun moves along vertically in a certain angle through a semicircle, maybe I can say that. Yeah, so the sun is going to be moving from below. Say it starts at night, right? It starts at night. By 4:30 it comes up a bit. By 6 most of the places have its sunrise. Then it moves on top, and most of the places have the sun perpendicular to the earth during the noon. So this will be the peak, and then it moves down as the evenings or the day goes through, and at night it sets. Now what we need to understand is, since the sun is not in a straight line, it's in a 3D coordinate, we need to know three significant angles in order to analyze the sun's rays or the sun's radiance on the site. So imagine you're lying down now, so you got to find out the horizontal angle. The horizontal angle is calculated in such a way that you need to have a hypothetical line drawing along the north-south direction at the site. So this forms a line, right? The angle between this exact north-south line and the angle drawn vertical originally on the site. The site would have 4 directions, right? Like top, down, right, left. There you find out the north-south direction and draw a vertical. So there will be an angle between the true north-south and the north-south of the site. This angle will be called your azimuth. Now, the sun is along a semicircular path on the sky, forming an angle to the earth, right? Now, the angle formed between the sun's position and the horizontal would be called your altitude, hence showing the height-wise angle. You can call it like that. But then it's not on a vertical perpendicular angle, right? So there is a difference between the true vertical perpendicular angle and the sun's position. So to show this difference, to complete the sector, this angle between the sun and the perpendicular drawn to the surface of the earth will be called your zenith. Next, we are going to be dealing with the sun path chart. how to read the sun path chart. Now, the most commonly used sun path chart would be a circular one, wherein you will be having concentric circles and arcs on the circles touching from one side of the circumference of the outermost circle to the other side of the circumference. This is how the diagram looks like, right? Now, if you consider it like that, the concentric circles will be showing you the angle. That would be the sun angle. Now, how do you determine the sun angle at a particular month? Is the corners at which the intersection point at which the arcs meet at the outermost circle's circumference will be giving you the months and the dates. Now, if you look at each arc crossing through the concentric circles, every intersection will be a given time. Like, let's say you draw concentric circles for 24 hours. So each circle will represent 1 hour. So how do you analyze the solar chart? How is it going to be relating to your site? This is in such a way that in your circular sun path diagram, you will have two perpendicular lines going all through. These lines will be representing your cardinal directions, east, west and north, south. So according to that, your sun path arcs will form, and when you try and mark, you will be able to analyze the sun's position at any given date and at any given hour. Now, for basic solar design, the main things we will be considering is the sun's path during the summer, the sun's path during the winter, and the solstice. So you will know the sun's position and the impact of sunlight on the site throughout day. According to that, you will be able to come up with shading devices, sun receiving devices, and you will be creating shade in your site in such a way that you avoid the sun where you do not need heat coming in, and you draw in more sun's radiation by giving certain design elements to absorb more heat in that particular space in your given house. Let's say, for example, you need to allow a lot of sunlight and heat on your kitchen. So you position your kitchen in such a way that the sun's rays falls on most of the hours of the day. And the space where you don't need too much sunlight would be, let's say, your bedroom. So you will place your bedroom in such a way that there is no direct sunlight hitting your window throughout the day. So you can keep your bedroom pleasant. This is for a tropical design. Again, the sun's position changes during the summer and the winter depending on its geographical location, right? Such that you will be changing your building design as well. Some of the shading devices would be your window sunshade, vertical films, louvers, temporary shades like gazebos for shaded outdoor space, and some of the light or the sun heat or the sun's radiation receiving design elements would be your trombe wall, light shelf, solar chimney. Now these three design elements will be mostly, you get the logic? I hope so. So have a look at the slides after this video, and you will be able to design a passive solar building by placing the sun's shading devices like the louvers, the vertical fins, and the window system accordingly. I would also like to mention that there is a software, or let's say an app called HEED. This really helps you in solar analysis. Have a look, it's a free app. When you download, you can try and play with your site and try to analyze the solar path so that you come up with the most efficient building design. All the best, guys. See you in the next video. See you. Bye.